All right. Whoops. You're going to get another email now. I just sent this out for everybody. This exam is going to be able to replace exam 3 if the score is higher. Does that understand? All right. It'll be due by October 26th. You do have extensions on all that stuff right now. That all will be due, though, at that point. Okay? There will be no more extensions. Okay? What was the other thing I was gonna say? There was something else. All right, just hold on. I don't know. All right, so let us begin. We're gonna finish it now, though. So we did this. We did this. I guess do number 3 here, please. Tell me what you got. Hello. Does it say anything about normal there? Yeah. Number 3. So nobody in here knows how to do this? I mean, I don't even see you guys doing anything. Okay. Then what though? I mean, did you take any notes last time? So why don't you look at them? I don't know what you're talking about. Square what to say? No. What's your answer first? 25%. So, I mean, there should be a lot of things you can do here that really should be few of them should be pretty easy. If we write like this is 6 and this is 12 here, and someone says that they want to get numbers between like 8, what is this, 0.5 and 10, right? It's like saying, what's the chances you can select that dark purple stuff out of that yellow stuff? Is that correct? So, I mean, I don't think it's that bad to say that you could just do 10 minus 8.5 divided by 12 minus 6. And this is 1.5 over 6, which is 1/4. So that I think you should be able to say, really. Does that make sense? But what we said before was that, and this is what I was expecting you to do, really. We said it would go between 6 and 12. Is that correct? And then it would have to be uniform here, or the same chance there. Is that right? Then what did we say to do next? No. Well, I mean, yes, but the thing is that we need to think about it in terms of the area, right? So if this thing has a height to it, then it's going to mean that this is like 6 times that height has to be equal to what? 1. So then P would have to be 1/6. And then they say 8.5. So what is this, like so this is 7, 8, 9, 8.5 to 10. So like honestly, even if you just think about this in terms of fractions, you should be able to tell me that you should be able to calculate the fraction. Does that make sense? And that's the same thing I'm really doing over here. It's just 2 different pictures. Does that make sense? So this one is really just like basic fractions. Does that make sense? The other ones may be different, but this, so now if that's 10 right there, and this is 8.5, we want to find the distance between those 2 places. So that's 10 minus 8.5, right? So then the area of this part right here is 1.5 times 1/6, which is the same thing I just said before. 1.5 out of 6 is 1/4. So we get 25%. Does that make sense? Question? Does it make sense, guys? The only reason why I'm going over this is because I think it's really easy to forget how to calculate what that part is right there. Otherwise, I think it should be easy. Because you have to be able to tell me you know how to calculate the area of a rectangle. Does that make sense? Question? All right, this one we did before, 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 this one. All right, how about this one? Is this the same worksheet? No, it's not good. All right, so how do you do number 10? The Precision Scientific Instrumentation Company makes thermometers. They're supposed to give readings of 0 degrees centigrade at the freezing point of water. Tests on large samples of these thermometers reveal at the freezing point of water, some give readings below 0 degrees and some give readings above. Assume that the mean is 0 and the standard deviation is 1. Also assume that the frequency distribution of errors closely resembles that of a normal distribution. A thermometer is randomly selected and tested. Find the temperature reading corresponding to the given information. Find P40, the 40th percentile. What would you say? And again, I don't know, I didn't say this enough last time really, but what I did say at the end was that please, 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 the minute they start telling you something about a normal distribution, try to start drawing the picture. Does that make sense? How do you draw the picture? What do I have to do to draw the picture? Yeah, well, I mean, draw it correct. Okay, I mean, that's correct. You draw, something like this. The hump, the hump, the hump, the hump. You like Fergie also. So okay, Beyonce, Fergie, I see what you like. All right, so the you're gonna have to come over here so they can hear you on the microphone also, because remember, we gotta make sure people hear you. All right, so no, but okay, you're right. Thank you. By the way, you go like this. You're right. No, but no, but what else do we have to do to label this? What's the other thing? The next thing that we would have to do to label this? Mm, no, there's something else we got to do first. Can't really know what to shade yet. Some other problem. Yeah, we got to label some numbers somewhere, right? So which numbers do we label first? 0 first. Okay. We need to label where the center is first, right? So then like 0. Is that correct? Because they said here that this thing is closely resembles a normal distribution. All right. And then they said that the mean is 0 because I am not going to know what the average is, right? They have to tell me. Does that make sense? Unless they give me data or something. Is that right? Okay. So then we have 0 here. All right. So always, 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 first thing you do is label this and then state what the standard deviation is. In this case, the standard deviation is stated as uno. Does that make sense? All right, but they have to tell me this crap in the question because there's no way I'm figuring this stuff out. Like if they start talking about women's, keep saying this dumb example, but I keep saying women's heights, right? They talk about the weights of something. They talk about ball bearings being produced by a machine, and then the weights of those ball bearings, right? They talk about cookies and how many chocolate chips are in the cookies. All right, it's not gonna, or the weight of the chocolate, I should say, in the cookies. Does that make sense? It's not going to really make any difference which one of these things they're referring to, but I need to start saying what's the mean and what's the standard deviation. But I'm not going to know what those things are. They're going to have to tell me in the question. Does that make sense? All right. So you need to identify which distribution it is, right? The previous one we talked about was like this. What was this guy? Uniform distribution, right? Then in this one, we have to talk about normal distribution. But again, they're going to have to sort of tell me something, or they're going to have to describe something. So I'm going to be able to tell what type of distribution they're doing, right? Then you need to draw it. Does that make sense? All right, great. I drew it. Now what? Now you got to actually be able to read the question. So explain me, please. Don't worry. I'll wait. I want the thing labeled first before we start discussing what we have to do. All right. So how are we going to go about labeling this completely to answer the question that they're talking about here? Because this one is a little bit more confusing in terms of what they're referring to. I've said it a few times last time at the end of class, but we never did an example. So what you going to do? I mean, we got to label this thing somewhere, right? I mean, that hasn't been included anywhere. Is that correct? Great. Where does it go? Can you show me what you mean? I mean, like, get up. Get up, though. Por favor. Yeah, I took 4 years. Me too. Help me, bro. What does that even mean? No, but I mean, like, what does that mean? Why? Anyway, just the way you say it. Anyway, like the. All right, go ahead. If you go from the left, I mean, yeah, sure. Well, it's sort of like we say, like over here, negative infinity to infinity, but it depends on what you're really referring to.
Okay, so depending on the type of information I think.
Right. So this one's giving this one. So I want to know how I use this.
Yeah. So if we talking like from 0 to 100, this is like the 50. This is like the 50%.
Okay.
Percentile, right?
Yeah.
So you gotta. So if we had 80 everything, or you can just by not by not. 40 percentile is somewhere around enough
That sounds good to me there, my friend. All right, so this right here, somewhere over here, somewhere, we're gonna say that that's like P40 right there. Is that correct? All right, bro. All right, bro. Because over here somewhere, like that means it's gonna have to have at least 50% of the data less than it, not 40%. First 40th percentile means it needs to have 40% less than it. Okay. No, that's not the right word. Okay. We'll do some examples with stuff to the right though also. All right. But this thing, P40 here would be somewhere over here. But still, where does the 40% come into play? What's 40%? You're right though, the position would be over here. But I still think that's confusing on how to actually answer the question. But that is, you're like 95% of the way done right now. Go ahead, money. Very good. Very good. Okay. So like 40% would be the area over here being shaded. Does that make sense? Does that make sense? All right. So that because 40% of the stuff is less than this number, right? Which would mean that what? 60% is greater than it. Is that correct? P40 from chapter 3, they said percentile means like, so if you're in the 88th percentile, that means you scored better than 88% of the people taking the test. So P50 would have to be directly in the middle is correct. But you have to think about it in terms of the area, all right? And this was the thing that we were talking about before that I was saying was a little bit easy to make a mistake on. Like, where are we talking about the values that go on the bottom here? Or are we talking about areas or probabilities? Areas or probabilities are always inside here. Does that make sense? Does that make sense? Right? Do you get it? All right. So then now it should be pretty easy to answer the question, actually. So how would we answer this? So they say they want to find the value that this thermometer would be reading such that it would be in the 40th percentile. How would we do that now? So how am I going to figure out now what is the value of P40? Sure. Yep, that's correct. So then the thing is good, by the way. All right, so we would do inv norm of 0.4, and that's all we really need to do here, because the area to the left, right, is 40%. Does that make sense? But again, because they're providing us an area in this case, we're going to be using inv norm, right? Because normal CDF was telling us the probabilities given positions or values. Is that correct? And then inverse norm is the other way, right? It even kind of gives you a hint here when you're doing this thing. So the more you keep using the calculator, the more you're going to get used to the fact that this is what it's going to be asking you for, right? And now it's sitting here and asking me for area in this case. Well, I actually have an area, right? But this is why it's important to draw the picture. Does that make sense? All right, so all I do is type in 0.4, blah, 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 blah. And then we don't need any of this crap. And they say this is the answer, negative 0.2533, whatever this is. So that would be the temperature reading that would be in the 40th percentile. Yep. I haven't told you what those things mean yet. So we haven't had to yet. Honestly, you never need it. All right, so provide an appropriate response. Which of the following is true about IQ scores? All right, so a lot of questions in this book want to discuss something about IQ distribution. A lot of times IQ distribution is assumed to be mean 100, standard deviation 15. Sometimes it'll start saying mean 100, standard deviation 10. Okay, but they say they're normally distributed. Does that make sense? So don't necessarily worry about this question, but a bunch of the questions will ask you something about this, so then they'll start stating it. So then you see in this question, they've stated it here. Does that make sense? All right, we're going to do this question a bunch of ways. But the first way I do it is the most important way in terms of understanding what we need to understand for the remainder of the course, the next 3 chapters. Does that make sense? All right. But once you understand this here, it's kind of going to be the same thing over and over and over again from today on. Does that make sense? Okay. So there's not really going to be too much more that we're going to have to learn how to calculate. Does that make sense? There's going to be different things that they're going to apply in terms of this stuff, but no more really calculating probability or anything. Does that make sense? They're going to ask us to calculate, but it's going to be the same type of calculation, not new, not another idea, really. Does that make sense? All right. Which I think is kind of good. And I think that's kind of neat, actually, that like a lot of things in statistics really you're going to be able to do with just this. Does that make sense? All right. So find the area of the shaded region. The graph depicts IQ scores of adults, and those scores are normally distributed with a mean of 100, standard deviation of 15. All right. So I just used this example because honestly, this was the exact same example that was given to me when I was a kid. And I don't know. I just always relate everything back to this. Does that make sense? There's one more example I'm going to talk about with Coke cans, filling up Coke cans with soda. And that's another one that we always talk about. All right. All right. So what I want to say is that there's going to be like some normal distribution here. So we say like, let's say IQ scores. Sorry, the pen is like not working. I think I have to buy a new tip. All right. So then IQ scores, which are normally distributed with a mean of 100 and a standard deviation of 15. They're interested in this particular IQ score here, 110. Does everybody see that? Right. So this is find the area of the shaded region. Does that make sense? The question could also be saying, find the probability that someone's IQ score is going to be less than or equal to 110. Or it could be saying the probability that the IQ score is less than 110. Why are both of these the same? No. Yeah, that's what I'm saying. If one has a possibility of being equal to and the other one doesn't, how am I saying they're going to be the exact same thing? What were you saying, sorry? Continuous, not discrete, right? Well, no, this one's saying all the stuff less than or equal to 110. This is saying now you could have less than 110, so maybe you could have like 100, 109.8 or whatever, or something like that. But like this one score is missing now. And I'm saying it still gives you the exact same thing. So the reason why I'm just trying to remind you, last class we talked about this a little bit, but like that one score right there, right? That doesn't have any area. That's correct. Good. Does that make sense? And then since it doesn't have any area, the probability of getting that one individual score is actually 0. Does that make sense? So these two are actually the same thing. So whether I say what's the probability that the score is less than 110, or I say that what's the probability that the score is less than or equal to 110, because it's a continuous distribution, right? Continuous. Does that make sense? Then it's going to give you the exact same answer. All right, but all of these things are the same question, right? So we could be saying find the area of the shaded region. We could be saying find the probability the random variable has a value less than or equal to 110. Find the probability the random variable has a value less than 100. They're all the same question. Does that make sense? Does that make sense, guys? All right. All right, so now we actually have to calculate something, okay? But I haven't taught you how to calculate anything with a non-standard normal distribution. Does that make sense? What did standard normal distribution mean again? That's correct. Standard normal distribution. Just to remind you again, we said Z, right? The Z score, is that correct? Right? Remember we did all that nonsense? The Z score is normally distributed with a mean of 0 and a standard deviation of 1. But you have to know that, all right? Because there's going to be questions on your test where it's going to be like, blah, 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 blah. If it's standardly normal, what's the answer? If it's normal like this, what's the answer? You need to know this one means mean 0 and standard deviation 1. Does that make sense? Okay. But it turns out, so like every normal distribution sort of looks the same. They have like the same type of shape. Does that make sense? All right. It turns out if I figure out what the Z-score of this position is, right? Or I consider that I do like Z equals to X minus the mean divided by the standard deviation. What did Z-score mean again? This means the number of standard deviations away from the mean. Does that make sense? If I calculate the Z-score for this particular position, we know already that if I do Z is equal to X minus mu over sigma, right? Then the average Z would have to be 0. Is that correct? The standard deviation of the Z's would have to be 1. Does that make sense? Does that make sense? How would I calculate the Z-score here? What is the Z-score? Sorry? Should be able to do it in your head, honestly. 0.66666 or 2/3, right? 0.67, you should say, right? So this is going to be Z is equal to, if I do X minus mean over standard deviation. Again, this is from chapter 3. This was the stuff, this is why they were going over it then. Does that make sense? All right, so X is what? 110 mean. They have to tell us, right? Does that make sense? Does that make sense? So then this is a hundo. Standard deviation is 15. So all I was saying is you could do in your head 110 minus 100, you get 10, right? 10 divided by 15 is the same thing as 2/3. Does that make sense? So then this is 0.66 whatever 7. Does that make sense? It's going to keep going, right? So it's about a little less than 1 standard deviation to the right. Does that make sense? All right. So then Elvis has entered the building. So sorry. This so this is the idea now. All right. Since all these normal distributions have kind of the same shape, if I determine what the Z-score is here, right? And this Z-score we said was 2/3. Is that correct? The area over here and the area over here, they're going to have to be the same thing. Does that make sense? Does that make sense? They're both normal distributions. I'm just relating this to the distribution that I understand. Does that make sense? So, what we could say, the probability that the IQ is going to be less than or equal to 110, whatever, is the same thing as saying the probability that the Z-score is going to be less than or equal to 2/3. Does that make sense? How do we calculate this? Yes, sir. No, he said normal CDF. You're definitely going to use normal because this one's normal, right? That's correct. Normal CDF is correct. So CDF, because CDF means cumulative distribution function, right? That's the area or the probability. Does that make sense? That's what we need to find. Is that right? So what I got to do? Explain to me, please. See, this is where also you're going to start liking the calculator more and more and more, because you open that calculator up and go to normal CDF, it's going to start sitting there and asking you for stuff. Then you're going to start, it's going to help you remember what to do. That's all you got to figure out, though. You're doing the right, though. Normal CDF, and then you have to start doing the lower and the upper, and that's really all we need to do. So we need the lower z-score, and we need the upper z-score. Is that correct? What were those in this case? No. Nope. Say again? Negative infinity is correct. The lower, and we don't write negative infinity, we write, that's right. Negative 1e99. Very good, guys. Negative 1e99. You guys are remembering like the hardest parts. All right. So then but not the easy parts. So then no, but you just need a little bit more time. Okay. But if you remember this, I'm serious. Remember the hardest parts, then it's not going to be that hard for you. Okay. So like negative 1e99, right? Then what does it go up to? Z score. We need the Z score because this is a Z. Does that make sense? 2/3, though. Is that correct? Does that make sense, guys? Just write 2 divided by 3 in the calculator. You see, it's a calculator. It'll do it for you. That's like one good thing about this stupid thing. This thing, so like if we do normal CDF, right? Negative 1e99, right? Just go 2 divided by 3. There you go, bro. Right? And it's just so don't even see, this is what I'm saying. Like teachers always sit here and they're like, oh, round it. Why? Let it do it. You know, who cares? Does that make sense? So and then on top of that, why would you want to round it? You're not getting as close as possible answers at the end, only at the end, right? Because otherwise, if you round in the middle, this is definitely going to change the answer. Does that make sense? Right? So then we have this number. Does everybody see that? Good job, guys. All right. So then this is, no, even if I don't delete it, it's not going to change anything. Because because I told you that the calculator, if I don't write those things, it's assuming those are there anyway. But the point is that the only thing you need to know how to do is understand what the z-scores mean and find the lower and upper z-scores. Does that make sense? You get what I'm saying? That makes it easy to remember. Does that make sense? Yeah. But if you write this here, it doesn't change anything. But I'm just saying, it doesn't matter if I type those in or not. Does that make sense? You understand? Okay. Right? All right. Good with this so far? Right, guys? All right. Now, the only thing is like I could write this like this also. What was this number? 0.7475, I believe. I could write this as P of Z is less than or equal to, and then I could actually write out what this would be. Like this would be like, what is this garbage? 110 minus 100 over, what was it, 15? Does that make sense? And then I could write that this is normal CDF, negative 1e99, and I could write the whole thing out here and just let it do it for me, the whole thing. Does that make sense? Does that make sense? The only reason why I'm saying this is sometimes you'll see this written in certain places, and then people get very confused sometimes when they start seeing all this crap. So, but I'm just doing it here. I'm just showing you, like, you can write it there. Why not? You know, what's the difference? Well, if you write the right thing. This, that. Does that make sense? It better give me the same answer. Does that make sense? Any question with this? Everyone okay with that? All right. So now I've gone through this a number of times. I've sat here and said a bunch of times, it's very important that you need to be able to draw these pictures. It's very important you do so for every single one of these questions. Okay. I'm really not kidding. You'll start doing them in like 2 seconds once you do it. Does that make sense? All right. Because you'll start getting the picture in your head. Does that make sense? And that's the important part. All right. And or one of the important things, I guess you should say. But you need to know what z-score means. Okay, I'm not saying this for fun. Does everybody understand what I'm saying? The next 3 chapters, the majority of your final exam is going to be about stuff that's required to know what z-score means. Does that make sense? I'm going to ask you questions on your final, which aren't necessarily going to be the entire process of what you have to do. But it's just going to be a part of it, a lot of them. Does that make sense? So you have to understand the parts. Does that make sense? You get what I mean? All right. But if you do, it actually means the question's easier because you don't have to do all the parts. Does that make sense? All right. So I'm just telling you, this part becomes important. But, all right. And this is why the people in the math lab end up explaining this way. And I was criticizing it previously. But there's another way we can type all this stuff in, and you don't really have to understand any of this, and you can still get the answer. So if I was taking my exam, what I would probably do is honestly do it both ways. Does that make sense? To make sure I understand if I'm getting the right answer, first of all right? Because I told you before, if you don't sketch these things out and stuff like that, chances are you type the wrong thing into the calculator, you're not going to have any idea. Does that make sense? That you did that. Does that make sense? All right. But, so for come on, man. But for non-standard normal distributions, well, actually, forget it. I'm just going to say it again. Normal CDF has a lot of ways you can type stuff into it. Okay? Normal CDF can take, so if X is normally distributed with mean mu and standard deviation sigma, all right? And I want to figure out what the probability is that X is going to be between, I don't know, A and B. Does that make sense? Again, always try and draw this picture, okay? I'm telling you, the people that will tell me it's easy. The people that won't will really have problems understanding quite often, all right? Whatever this is. Does that make sense? All right, normal CDF. So we said that if we do z-score will, so I skipped one part that I should have mentioned, all right? Because I was just explaining to you how to calculate it. But there is some like slightly, well, it's not slightly, I guess. There's a little non-trivial part here, which is we know that Z is going to have mean 0 and standard deviation 1. That we know. Does that make sense? But the thing I really haven't stated anything about is why, if I say something is normal to begin with, that if I start taking the z-score of those things, in other words, I subtract some number from all of them and divide by something. Does that make sense? Right? Because z equals to whatever the x value is minus the mean divided by the standard deviation. So if we subtract some number and divide by some number, it turns out it still remains normally distributed. I have not explained that yet. Does that make sense? Does that make sense? All right. But that part's not that crazy if you think about it. All right. There's some other stuff that we're going to be able to say that's even more general, though. So we're going to talk about that. But I did not explain to you why this is normal yet. Does that make sense? You should really be asking me, why are we still allowed to say that? Does that make sense? Mean 0 and standard deviation 1, I did explain that. Okay? We did that before. We spent a whole day on that. So then this here, the z-score now will have mean 0. There will be some z-score associated with this lower position. There will be some z-score associated with this upper position. Z lower will equal to A minus the mean divided by the standard deviation. Z upper will equal to B minus the mean divided by the standard deviation. Does that make sense? Does that make sense? The number of standard deviations those things are away from the mean. Is that correct? In other words, this thing here is equivalent to saying the probability that Z is between Z lower and Z upper, which is the same thing as saying A minus the mean divided by the standard deviation is less than or equal to Z is less than or equal to B minus the mean divided by the standard deviation. Whatever those Z scores are. Does that make sense? Does that make sense, guys? All right. Well, how would I calculate this using normal CDF then? All I would have to do is type in the lower Z score and the upper Z score. Is that correct? Does that make sense? Does that make sense? But this was really saying that the mean was 0 and the standard deviation was 1. Is that right? And then we can type it this way also. We don't write the mean is 0 and standard deviation 1. And the calculator just assumes that those are what they are. Is that right? Those are the default values, right? Well, there's another way. So if I want to talk about the x's here, and the person doesn't understand what z-score means at all, but they know it's normally distributed. Does that make sense? The calculator will also let you write the lower x value, the upper x value, the mean, and the standard deviation. In other words, in this case, all I would have to do is write A, B, mu, sigma. Does that make sense? Does that make sense? How would you use this? It's on the video. So the you can though. But but I want to just do it with this question real quick. I want to use that idea to do this question. Does that make sense? So how would I write it this way for this question? What would I have to do? What would I have to type into normal CDF? Somehow this should be this really should be really easy. So right here, sorry, the previous question we were doing, does that make sense? So the same thing we were trying to calculate before, right? Kamani, go ahead. Very good. Negative 1e99. 110. Not 0 and 1. We need to use the mean and the standard deviation from the distribution that we were talking about. So in this case, the x has a mean, or the IQ has a mean of 100, right? And has a standard deviation of 15. Does that make sense? Right? Now, like, watch this though. So you go in here, normal CDF, right? I type in, what did I just say? 110, 100, 15. Now, I mean, like, if you tell me this is hard now, no, wait. I'm talking about like in terms of the actual question. So like all this stuff together, yeah. There's a lot to talk about. Does that make sense? I'm just talking about doing the actual problem now. Does that make sense? All right. So you read this question. You have no idea what's going on, let's say. Okay. Let's say they don't even give me the picture here. All right. And it says find the area of the shaded region. The graph depicts blah, 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 blah. And this thing, mean of 100, standard deviation of 15. Let's say instead of saying find the area of the shaded region, it says find the probability that the value is less than 110. Does that make sense? Does that make sense? Okay. So why am I saying this is easy? Because this would work. All right. Because if I come into the calculator, so let's say I don't know what I'm doing. Well, better, otherwise I'm stupid, right? I'm wasting your time otherwise. So then this thing, second distor here, right? Well, actually, excuse me. I could be stupid anyway. That has nothing to do with this. All right, but this, so like normal, we should be coming in here, and then we should be asking ourselves which distribution, right? Yeah, well, that's easy. It says normal in the question. Does that make sense? So then you know it's one of these. Is that right? Well, we didn't even do normal PDF. It ain't that one. Does that make sense? Right? Remember I said you bring your toolbox? Does that make sense? Right? So if you bring your toolbox, then you're like normal. I only got these two choices. I just got to know what they mean, right? Normal CDF means it's going to give me the probability. This one means it's going to give me the value. Is that correct? Well, I already got the value. Does that make sense? I need the area. So then fine, we go to normal CDF. It says lower. Great. There is no lower here if we've drawn the picture. Upper, yeah, I mean, it says less than 110, so it's not hard to say that. Does that make sense? Then mean, I mean, they told me in the question, standard deviation, they told me in the question they have to. Does that make sense? Otherwise, I can't answer the question, right? I don't know what the mean IQ score is or whatever. Does that make sense? So then we push this, and then we're like, go. And then we're like, wow, that was easy. It has to. That's the point. The point is there's multiple ways you can calculate it. Does that make sense? No. It's not a shortcut. No, it's not longer. It's not longer. But they're all like this is not really very long. I subtracted one number and divided. Does that make sense what I'm saying? I don't think any of these are long. Do you get what I'm saying? But the point is that you have to know what z-score means. So when I was in school, my teacher never taught me this. The calculator didn't even used to do it. The original TI-83s or whatever, it didn't used to do it because they were trying to force you to use z-score. Does that make sense? But it's all the same crap anyway. All right. But if you do not understand what z-score means, you will be in big trouble for the next 3 chapters because there's going to be every question is going to need it. All right, so that was that. Great, whatever. Oh yeah, so now this. Okary dokary. All right, so I have to write this one out too. But there's going to be a nice way to do it on the calculator as well. All right, it's a very similar type of question, but the thing is what's the difference here? Say one more time. They're giving us the area now. We're not looking for the area anymore. Is that correct? What does that mean? So we're going to look for the value is correct, but what does that mean? We're going to be, this is like the inverse problem. Does that make sense? So that means we're going to have to do inverse norm now. Does that make sense? So this chapter to me, questions are easy. All you got to do is sit there every single time and start saying normal. It's one of these two things. Does that make sense? You got me? You just got to know which one's which. You understand? All right, this stuff's not going to be that bad. Okay. There's going to be something about the central limit theorem that we have to talk about. That's kind of a lot, but the questions are still easy. All right. So the finding, but that's the whole point of the whole class, the central limit theorem part. All right. So find the indicated IQ score of this graph depicts whatever this stuff is. Okay, so this is 0.5675. Again, there exists a distribution that we seem like we understand a little bit better that has mean 0 and standard deviation 1. And this is the standard normal distribution, right? Does that make sense? There exists some position here which has the exact same area. Does that make sense? We can determine what this z-score is here. How do we know what that z-score is right there? No. Yo, Beyonce is gonna be pissed. You just messed up. Beyonce's gonna be pissed. Jay-Z, Beyonce, they coming. What's the deal? What does Beyonce say? To the left, thank you. Did you do to the left? No, if you do 1 minus this, you're doing to the right. Does that make sense? You got me? I'm telling you, Beyonce was trying to teach you statistics. You don't believe me, but she was. She's good at stats. She knows what's up. Look, though, seriously, though, okay? The calculator expects you to type in there to the left. Does that make sense? Right? You need to give me the area to the left. Does that make sense? So this particular z-score here is going to equal to z equals what? How do I write it? Yeah, but I don't know, like, if we do x minus mean over standard deviation, we don't have all that stuff yet. Does that make sense? I'm just asking you, what is the z-score? Nope. We did this last class. And we did it earlier today already. You guys already told me which function you need to use. So just do it. Nike. No, that's not what I'm asking right now. That's not what I'm asking for this question. I'm asking you what the z-score is. That's the correct final answer, but I'm trying to tell you that sometimes I'm going to be asking different stuff, and if you don't know the rest of this, then it's not. Sorry? How do you do that? All you have to do is type in the area. So then this is going to be just inverse norm of 0.5675. But honestly, guys, like every single one of you should be able to tell me this. I have no idea why you're not telling me this. Okay, we just did this a couple of minutes ago. Where was it? Sorry. What'd you say? No, we did it here. This was 0.4. Does that make sense? And we said this. Is that correct? Right? Same picture, it was just different area. Is that correct? Does that make sense, guys? Do you understand what I'm saying? It can't be 17. 17 is way too big. 0.17 maybe? Just do inverse norm here. Second vars, right? Inverse norm. Then the area to the left of the position that we're interested in is 0.5675. Does that make sense? Doesn't matter. Doesn't matter. I don't even use it. Honestly, see, it doesn't even make, it just doesn't even make any difference. All right. So this thing here is 0.17. Does that make sense? Does everybody see that? All right. What does that mean? So this is this number is approximately 0.17001288. I'm just gonna write the whole thing. 0.17001288. It's at 7, I believe. 07, thank you. So then the this, right? It's not really a matter, to be honest, but the thing is here, right? If we understand this part that I'm about to do right now, this is all of chapter 7. This thing I'm about to do. This one step right now. Okay? Does that make sense? All right. I mean, there's some more stuff to know, but this is the majority of the math. Does that make sense? All right. So now the thing is though we actually know what mu and sigma are. Is that correct? Right? I didn't need to write mu and sigma here. I could have written 115 because x was normally distributed with mean 100 and standard deviation 15. Is that correct? The IQ score. Does that make sense? Right? How would we solve this? Because really what they're asking us for now is, we know what the z-score is. We know what this is, right? We need to know what that is. Does that make sense? That's right there. Does that make sense? Go ahead. We need to get the x by itself. How do you get the x by itself? So that's correct. So wait, let's just write it like this, and I think it'll be a little easier. No. Multiply by 15 is correct. First thing, because it's everything, you gotta get rid of the stuff that's been done to the x, right? So they're like, oh, you gotta subtract 100 first. Is that right? Then they divide by 15. Does that make sense? So it's like, how did you walk into the building, right? When you walked into the building, you had to come through that door, then you had to come through this door. Is that correct? If you walk out, you have to walk out in the reverse order. Does that make sense? So the last thing that was done to the x is the first thing you got to get rid of. Does that make sense? In this case, we're going to multiply by 15, right? And then we would end up with x minus 100 equals 0.1700128807 times 15. Does that make sense? Then we would go, and you're right, add 100 to both sides, right? And then they say this is x is equal to 100 plus 0.1700128807 times 15. Does that make sense? Now, one thing though, I don't want you to type it this way. Does everybody understand what I'm saying? All right. What I want you to do is this. So, well, it has to. So the thing is though that they want us to understand this formula for the next chapter. And right now, some of your questions actually have it. So we don't have to keep doing this over and over. Does that make sense what I'm saying? Okay. We can do this one time and write the formula. It's going to be the same each time, but we need to understand what the formula means in this other form. It's helpful to understand the next chapter. All right. So that's why they're trying to introduce it now. All right. Every time, if I want to solve for x, right? Oh, multiply by sigma to get rid of this guy. Does that make sense? Right? Then we end up with x minus mu is equal to z times sigma. Then we have to solve for x. So I would add mu. X equals mu plus z times the standard deviation. Does that make sense? All right. Now, why does this formula make any sense? Okay. The way we have to say this a little bit because it helps in the next chapter. All right. So this is what? The mean, right? Plus z-score, which means the number of standard deviations away from the mean. And then we're multiplying that times the value of the standard deviation. Does that make sense? Now, I said this before, but this is the only thing you really have to understand with this, okay? If you start off with $100 and you make $5 a day, and I say you've worked 3.5 days, how much money would you have? If I started off with $100 and I made $3 per day, right? Let's say, okay? Actually, no, let's say 5. Let's say $5 a day. No, 10. Let's say $10 a day, just because make it easier number. All right, $10 a day, and then I end up working for 3.5 days. Does that make sense? It's the same idea. Does that make sense? If z is the number of standard deviations away, and then I multiply it times z, then z times sigma has to tell me how far away I am. Is that correct? If I add that to this value, it would have to tell me the value we're interested in. Does that make sense? Does that make sense? The number of standard deviations times the standard deviation. Does that make sense? All right. Okery dokery. Now, this part here, the way I actually would like you to type it in is slightly different. All right. So the way I'd like you to type it in is like this, because I don't want to round anything. All right. So we do the mean, 100. Does that make sense? Plus, I don't really want this thing. I could just do this again. Does that make sense? Just go like that. Does that make sense? Now it'll calculate it. Is that correct? Huh? Push up. Push up. Push up. Yeah. Or push second entry. Either one. You know what? Just push enter. Huh? Okay. Now wait, there's another thing you can do too. So you can do this also. If you do this entry button, by the way, all this crap that I'm talking about, it doesn't matter what calculator you use, it all works the same way. Okay. So this entry thing here, right? If I click that second entry, it'll start cycling through all the previous entries you used. Does that make sense? And then I think on yours, mine doesn't work, but I think on yours, if you push up, it'll go to the previous stuff too. Okay. So like the, does it make sense, guys? That's every calculator does this stuff. So because you don't want to have to sit there and keep typing the thing in and again and again. Does that make sense? All right, 100 plus, right? So we want to get the number of standard deviations away times the value of the standard deviation. The value of the standard deviation in this case was 15. Is that right? And then we get this value. Does that make sense? Now, again, the function is overloaded, okay? So like overloaded again means, all that means is there's lots of different ways you can type the thing in and it starts giving you different responses. Does that make sense? So then like if you have mean of 100 and standard deviation of 15, and I start saying that I want to know the position here, X, such that the area is 0.5675 to the left, right? A bunch of you guys said you already did it this way anyway, right? So then X is going to equal to inv norm of, now it wants the area, again, to the left. Then it's going to mean, then you just tell it the mean and the standard deviation. It's what it wants. What do you want from me, bro? So this 0.5675, then the mean is 100, standard deviation is 15. Does that make sense? Yeah, but that part, I'm not going to talk about that part ever because a bunch of people's calculators don't do it. All right. So then some people's calculators don't even give you the menu here. Wait, let me just show you what some people's calculators give you. All right. Because when I was a kid, it didn't used to give you this either. All right. So then this 0.6, whatever, 100, 15. When I was a kid, the only thing it would give you was this. Yeah, it would just give you this. And then you just have to remember what to type. That's all. But you do it a couple times, you're going to remember it. Does that make sense? So then you would just say 0.5675, 100, and 15. Does that make sense? Right? Same exact value. Is that right? Now, the reason why I'm showing you this again is because, look, here, watch. If I use a program or a programming language, This is how I had to type it in this programming language. Does that make sense? Can you see it or no? Does that make sense? So it's a different function call for the name, but otherwise it's the exact same crap. Does that make sense? Question? I just said to you 2 seconds ago, I'm not going to talk about that. It's because I think you guys are idiots. That's honestly the reason. They literally are not trying to make sure that people understand anymore. And they're trying to make it an easier way for people to type stuff into the calculator to give people the answer. But then the problem is that the next stuff that we have to know, it causes them a problem. The next class, it causes you a problem. The one after that, it causes you a problem. So when I was in school, there was like a different philosophy that people used to approach things with, where they used to sit there and say, we're going to force the people to learn how to do it now so that they can take the next class. Now they think about it seemingly slightly differently, where they start saying, hey, we'll make it easier for people to pass this thing right now and get them through, right? Because most of them are really not going to have to go and do the next part. But the thing I don't like about that is I don't know how they get to tell you that. Does that make sense? Like, how do they know what you're going to like in a year or 2 years or what you're going to need? Does that make sense? And I don't want you to have to go and take the same stupid thing again next time and really have to learn it first then. Does that make sense? Because that's how people fail. Does that make sense? When there's too much to catch up with. So, but that honestly, I have to say that's the only reason why. Because if I go show you the programming language, I can't do that in the program. Does that make sense? And this thing is invented as a teaching calculator. So that's why it has all these different ways to do it. Well, no, they're just not trying to teach you anymore. Because if you go to the math lab, see what they say. See how they'll tell you how to do it. They'll tell you how to do this. You ask them anything else about it, they'll tell you they don't want to talk about it. And then it's because they really don't know any other way, because that's all the teacher showed them. Does that make sense? And I don't know. It just creates a little some problems. Does that make sense? Because it didn't take me that much longer to explain it to you anyway. Does that make sense? All right. So and then we're gonna need it in the next chapter, and then one after that. Whatever. All right. So then now I don't care which way you do it now, okay? Because I want you just to pretend like you're taking a test or whatever. How would you do this one though? Number 16. What would you say? Good. Inverse norm, definitely, because we're gonna have to do inverse norm because it's providing us the areas, correct? And we need the value here, right? So we're gonna do inverse norm of, what do I write? 0.9. Because you have to do it to the left. Does that make sense? And there will be questions I ask you on your exam where I will ask you what to type in the calculator. Does that make sense? So you will have to type it the way I'm saying it. Also, there's going to be some stuff later where if you don't do it this way I'm saying it, you're going to get very confused. Does that make sense? All right. 0.9, because that area is 0.9. Is that right? All right. What else do I type? The mean and the standard deviation, right? Does that make sense? All right. Now, what would the other way be to type this? You would type inv norm 0.9. What else would I have to do? Plus 100 is correct. Minus 15 is wrong. Times 15. Good. Does that make sense? The formula was the mean plus z, right, times sigma. Does that make sense? Does that make sense, guys? The number of standard deviations away times the standard deviation has to tell me the distance this point is away from here. Does that make sense? What is z? What is the inv norm of 0.9? What's the number? Somebody do it for me. Wait, let me see if I can remember. 1.68. Is that right? 28. Damn it. Oh, I did it wrong. I did it wrong. That's why. That was 80%. What's inverse norm of 0.95? 1.64, whatever. That was close. All right, so then this one, all right, so inverse norm, right? Inverse norm of 0.9 is 1.28. Lucas, look at this 1 second, sorry. 1.28. So this is saying 1.28 standard deviations away. Does that make sense? Does that make sense? Standard deviation is a number, okay? Okay, so if I say you're 6 feet away, right? Then you're 6 times 12, 72 inches away. Is that correct? Right? So now I'm saying instead you're 1.28 standard deviations away. Does that make sense? But a standard deviation is 15. Does that make sense? So if I say this times 15, this is 19.22 units away from the center. Does that make sense? Oh, this is 0.1, and then this is 0.9 over here. If this area right here is 10%, then the whole thing has to be 100. So that means this has to be 90%. So then this thing is just saying the distance that is away. So then if I add this back to 100, we get the answer. Does that make sense? And that should be the same thing as just doing it the other way. Right? Question? All right, then. Sorry? That's pretty much what you need. Right. But no, but the whole next chapter they do. That's what they always do this where they start like introducing the thing for the next part. Does that make sense? But you can see why they're doing it now because we're talking about normal distribution. Does that make sense? All right. So how would I do 17? Can somebody tell me how to do this one? Let's go through these kind of quickly because I gotta finish this. 17, 18. Tell me how to do those as fast as you can, please. Again, please try and draw the pictures also. All right. Try to get in the habit of drawing the pictures. I know sometimes you don't have to and you can think of it without doing it, but it's a good practice. Does that make sense? Because later on, like if someone asks you this crap, you're not going to remember everything. But you start drawing that picture, I swear to God, you'll start figuring it out. All right. You'd be surprised, like random jobs sit there and start asking you questions about this stuff when you get try to do the interviews. Sometimes no. Sometimes they'll just say, well, how would you do it? And then you have to tell them, I'm going to do it on the calculator. Then they'll be like, oh, how would you do that? And then you start explaining it. But the thing is I know what you would need to type. You know what I mean? So if the person just starts telling me the right thing, I'm good. Does that make sense? You get it? Yo, you all right, Beyonce? Nobody knows how to do this first one? Okay, that's correct. Yep. So what do I type? Mm-hmm. That's it. This area here needs to be 0.25 now. They want that position. Is that correct? Does that make sense, guys? 0.3, they have to tell me. How do they get 0.5? First quartile. Quartile, right? Quarter. Does that make sense? Question, guys? All right, this next question pisses me off. I can't stand it when people get this wrong. Everybody gets it wrong though. It's reading though. It's not math anymore. This becomes a reading issue for this question. Does that make sense? Somebody tell me how to do this guy. I'm giving you a little bit of a clue by saying all that at the beginning though. All right. But how many answers do I need for this question? Is it 1, 2, or 3? How many different answers do I need? So then you're saying 2 answers? I don't know what you're saying. 2 answers? Is that what everybody says? Joel, you say 1? Why do you say 1? That's correct. So the thing is that it's actually only 1 answer in this case. And if you draw the picture, you're going to tell me it's obvious. Okay? So this here, if I say separates the top 59% from the, whoops, I've drawn it backwards. Separates the top 59% from the bottom 41, right? 59 plus 41 is 100. Is that right? This separating thing is only 1 value. Is that correct? Does that make sense? You understand what I'm saying? That the reading part here becomes an issue. Does that make sense? Okay. But my point is read it slow. It's not going to take you that long to do it. Does that make sense? Right? Draw the picture. It'll help you a lot. I promise. All right. So then we're going to do what? Inv norm of 0.41 is to the left, right? 37.3 and then ocho. Does that make sense? Does that make sense, Lucas? Question? No, because the problem is if they say bottom 41%, right? So like just so this thing, imagine it like a room with like area. Does that make sense? So then like if I say to you, I'm gonna split this somewhere. Does that make sense? Then I'm saying to you that 41% of the area is on this side. The bottom 41%. Does that make sense? But then automatically, if this is the bottom 41%, this side would have to be, because the whole thing has to add up to 100. This is 41% plus something has to be 100%, or 0.41 plus something must be 1. So X must be 1 minus or 59, right? This side must be 59%, right? So that's what they provided you, right? But the thing is that if I say to you, find the value, right, that separates the bottom 41% from the upper, it has to be just one of these. Does that make sense? But again, I am not saying this because this is the first time for me seeing someone having difficulty reading this particular thing. Does that make sense what I'm saying? All right. And it's more common that someone reads it the other way that you guys were originally interpreting it. But then once you draw the picture, you can't have those. There's not 2 values. Does that make sense? All right. So just again, try to draw the picture. Okay. Question, sorry. No. Do it. You got a different number. First of all, how would you get the same answer? Look, if I do 51, oh, okay, maybe you didn't do it yet and you're just trying to think about it. So that's a good question, actually. So then the thing is like here, 0.59, 41, right? That place, yeah, because this thing is like less than the mean, and that guy's greater than the mean. Does that make sense? Right? Sorry, Kamani. What do you mean? I'm not going over that for the 6th time. All right. So you should be able to figure it out. It should be obvious. All right. But I'm just telling you, I wouldn't do it. All right, so a bank's loan officer rates applicants for credits. The ratings are normally distributed with a mean of 200 and a standard deviation of 50. If an applicant is randomly selected, find the probability of a rating that it's less that is between 200 and 275. Also, another reason why I'm saying this, like, there's many other types of distributions. Everything is always written in terms of this CDF format to the left. Does that make sense? To the left, every time, to the left, to less than or equal to, less than or equal to, percentile, less than or equal to, less than or equal to. So then the problem is that every program works this way, to the left. Does that make sense? So they made that one thing in that calculator work to the right. I don't think it's a good idea. Does that make sense? Because then the person, when they do all the other things, they can't do that anymore. You understand? To the left. Yeah. Right. And then on some of the other functions in the calculator that we've already done, it was binom CDF. You can't do to the right. Does that make sense? It's they just did this one thing because there's a bunch of classes in a bunch of schools that are really low level, and they try to introduce this concept to those schools, and they're just trying to make it really easy for those kids. Does that make sense? But that's not really you guys, to be honest. Does that make sense? Like that you were talking about people that there's a class, two classes below this they used to have. It was just called Introduction to Statistics. That was the class. It's not even a college level course. Does that make sense? All right. A bank's loan officer rates applicants for credit. The ratings are normally distributed with mean of 100 and standard deviation of 50. If the applicant is randomly selected, find the probability that the rating is between 200 and 275. Somebody tell me how to do this one, please, quickly. Okay. Yep. But it says between these two. Does that make sense? So then 200 minus 200 over 50, but that's kind of dumb to do this, to be honest, because that's just zero. Does that make sense? Right? That's zero standard deviations away from itself. Does that make sense? Zero. I should ask you this, but all we need to do is normal CDF. Does that make sense? Now, of course, we can also do it the other way, just to remind you, right? We can say it's 200, 275, 250. Does that make sense? Does that make sense? Does that make sense? Question here, anybody? All good with this? The weekly salaries of teachers in one state is normally distributed with a mean of 490, a standard deviation of 45. What's the probability that random selected teacher earns more than 525 a week? What are the two ways I can write this one? Yeah, what do we got to write? What's the order, though? Guys, come on. I got to get this over with. 525 minus 490 over 45 is correct. What's the upper? Sorry? Yep. 1E 99. Does that make sense? Good. Then we could also write what? 525, 1E 99, 490, 45. Does that make sense? Everybody okay with this? Good. At 8. Okay. Let me see if I can just find something real quick, because usually I spend a little bit of time going over this. Second comma. Central limit theorem. Just going on. Yeah, boy, do you have it? Tell me you got this. All right, let me see if this works. I never actually watched this video before, but this guy is the best. This is the guy who invented everything for Khan Academy, and he. What's your question? I'm sorry. No, negatives on the other side. All right, let's see. This is 31 minutes, so I'm going to go through this kind of quickly. We're not going to do the whole video. You've seen this game before, is that right? You drop the balls into these things, right? So what he's doing is he's just dropping the balls into this thing. But then most of the balls sit there and fall in the center, obviously. Does that make sense? But they seem to follow a specific type of shape every time, right? Have you seen me write this stupid formula before, right? Imagine that. Why would they call it normal? This guy's videos are good. I'm just telling you. So he's just trying to give you another example of something that seems like it would be completely unrelated that would also follow a normal distribution. Does that make sense? Yeah, buddy. Come on, let's go. Right, whatever. You can go left or right. Does that make sense? I could show you how to calculate this, but this is not that important. Wait, he just said something important. This is the point. So, like at the beginning when we were doing this, like they could have fallen all over the place and didn't really look like necessarily like a normal distribution. But all of a sudden, when you start doing it a lot of times, right? It's hard to get the stuff to go really far away from the center that often. Does that make sense? Right? And most of it has to fall in the center. Does that make sense? So after a large number of times, it ends up following this shape. Does that make sense? Right? You do it a couple of times, anything could happen. Does that make sense? They could go way over there. Is that correct? Right? But if I do it like 1,000 times, there's no way they're all going to go over there. Does that make sense? If they do go over there, there's going to be some over there too. Does that make sense? If it's 50% chance that you move left and 50% chance that you move right, right? Then for me to go all the way right, I would have to constantly be choosing to go right. Right. But the thing is like if I want to stay in the center, right? Well, sometimes I can go left. Sometimes I can go right. Sometimes I can go left. Sometimes I go left like 3 times. Then I go right 3 more times. You see what I'm saying? Right. So I always give this example with with Coke cans in a factory. All right. They fill up the Coke cans in the factory. Right. They all are supposed to be 12 ounces. They're not. They're never going to be exactly 12 ounces. They're going to be a little higher, a little lower, whatever. Right. But then when we start taking the average of all of them, right? Does that make sense? So that's what he's talking about now. He's saying, oh, you're going to add all these things up. He doesn't really care about adding them up. He wants to take the average. Does that make sense? So he's going to add them up and then he's going to divide by how many there are, right? Let me just get to where he's doing that. He just keeps wanting to give you different simulations to show you that each one's resulting in a normal distribution. Does that make sense? All right, this one might be good though. Yes, this one's good. I want to do this one. Now he's using like a cheating die, okay? So wait, this is the part of the whole thing that's okay. You understand? This thing gets one more often. Does that make sense? Does everybody see that? So he just keeps adding up the numbers on the dice, right? He keeps rolling the dice 10 times. Does that make sense? But with this die, it's so easy to get one, right? It's going to be hard to get really high numbers. Does that make sense? He's doing this a few thousand times. Does that make sense? We can do this on the computer also if you want to. All right. But it's weird we're getting the same shape. Does that make sense? Because the reason why I find this very strange and interesting is that this original shape didn't look anything like a normal distribution. Does that make sense? Does that make sense? That's the part that's sort of interesting. All right. No matter what distribution you start taking something from, the minute you start taking averages, if you take a sufficient number of these averages, you made it more extreme now. But if he keeps going here, watch what's going to happen. So this one, he's doing it more often here. So now he picks a U-shaped distribution, which is almost exactly opposite of what a normal distribution looks like, right? Even you do this crap. Does that make sense? It starts becoming normal. Does that make sense? Because when I take averages, this is what happens. You're going to get some fat people. You're going to get some skinny people, but they end up averaging out. Does that make sense? Does that make sense? It's hard for me to get 50 people and them all weigh enough that the average ends up being 350 pounds. Does that make sense? It's hard for me to get 50 people and the average of all those people is 100 pounds. Does that make sense? If they're random. Do you understand the idea? Does it make sense, guys? Oh, good. That was a perfect time to stop, actually, because he was going to start deriving everything. All right. So then the thing is now central limit theorem. Again, this is really the whole point of this class. If this didn't exist, you wouldn't know me. You wouldn't have to take this class. Okay, this is everything. All right. So what it says is, if X has a mean and it has a variance, and n is greater than 30, X bar of size n. So in other words, if you sample 30, more than 30 elements from a distribution, with a mean and standard deviation, then the mean X bar satisfies the following. The mean of the means is the original mean. The variance of the means is sigma squared over n, which then means the standard deviation of the means is square root of sigma, or excuse me, is sigma over square root of n. Also, the last thing is that X bar n is approximately normal. So we summarize this by saying X bar n is approximately normal with mean mu and standard deviation sigma over square root of n. I guess we'll have to talk about this sigma part a little bit later, but effectively the only thing that happens is the standard deviation changes. Does that make sense? It gets smaller. Does that make sense? Which you would think it should, because it's hard for the average to vary as much. Does that make sense? Which he's going to go into in that video in a second. All right. Does it make sense here, guys? I got to do these questions though. All right. So these three questions here. This is going to take maybe 15 seconds. But I got to show you what to read for first. Does that make sense? Everything is practically the same thing as before. Okay. The only thing is though, there's one key word you need to notice here. All right. It says loan officer rates for credits. The ratings are normally distributed with a mean of 200, a standard deviation of 50, a 40 Well, first of all, they start talking about 40 applicants, 90 women, and 40 mechanics. Does everybody see that? We never did that before. Does that make sense? All right. Before, when we were doing z-score, we were like z is equal to x minus the mean of x all over the square root of the variance of x. Does that make sense? Does that make sense? Now, if we do this here, it would be like, now we're sampling X bars or averages. Does that make sense? So I get some average. I would subtract the mean, and I would divide by the standard deviation. Sometimes n is equal to 1. If n is equal to 1, you would get the same formula, because square root of 1 is 1. Does that make sense? Because this is the same thing as just x minus mean over sigma. If n is equal to 1, this formula would be the same thing as saying that. Does that make sense? Does that make sense? All right. So first, they start saying this crap, which is something different. Is that right? But the other thing that's really important is that it says find the probability that their mean have a mean height. That their mean. Does everybody see that? They're talking about the average now. Does that make sense? Not just the X. Does that make sense? A bunch of them. Average of a few of these X's. Does that make sense? Good. All right. So it seems like it's going to be hard, but it's not, because all we need to do is use normal CDF again. Does that make sense? We know how to use normal CDF. Does that make sense? So find the probability that their mean is above 215. All right. So then normal CDF, 215, 1E99. Does that make sense? Normal CDF between this and this, 62.9, 64. Does that make sense? Normal CDF less than this, negative 1E99, 7.6. Does that make sense? Now, all I need to do is put the mean and the standard deviation. The mean, the standard deviation. Is that right? Well, the mean's already given to me. The mean is 200. 63.6. 8.4. Does that make sense? Now, there is one part that changes. The only thing that we said changes here is the standard deviation. Does that make sense? Because it has to get smaller if we're taking averages. Does that make sense? So that's all we have to do. So now you just come in here and then it says the standard deviation is 50. So you need to make sure you remember to adjust the standard deviation based off of the number of people that they were sampling. So in this case, you divide by square root of 40. Does that make sense? There's 40 people, n is 40. Is that right? Now this one is going to be 2.5 divided by square root of 90. And this is 1.8 divided by square root of 40. Now the only thing is that in this question here, he tells you it's, in this one he says right here, it's normal. In this one it says it's normal. Does that make sense? This one does not say normal. Does everybody see that? But because they had greater than 30 here, the central limit theorem applies and the average automatically follows a normal distribution. Does that make sense? Does that make sense? So they don't even need to say normal and normal here. And I can do it this way. Does that make sense? If they say normal, of course you can do normal though. Does that make sense? All right, question? Wait a second. Hi. No. All right, just wait a second. All right, so then the question with this? Good? I guess that means she didn't come last week. All good? All right, that is all.